Hello students, welcome back to the online classes. So in this online class, what we are going to discuss, that is, already in the previous video we have finished off the wave optics concept. So right now, however, the offline classes are not there, only online classes. So we have taken slightly extra time to complete. Why? Because in a hurry we cannot do that. So in a proper manner, as much as possible, I have tried my level best to convince you people or to make you understand regarding the topic of wave optics. So however, you are having NCERT textbook with you people, so go through that once, so it will be more helpful for you. Okay, so today's topic is the upcoming chapter. The upcoming chapter is, you can see there, chapter 11, second PUC, and that is dual nature of radiation and matter. So dual nature of radiation and matter is the chapter name. So let me just introduce you in the sense what is this topic is all about. It's all about, initially ray optics concept when we started, of course we have just treated light as just a wave which travels in a given medium. It undergoes reflection, refraction, all those things. Later on, slightly some extra things, like apart from the geometrics, geometrical ray optics, what we started to study is, because of different scientists' theories and all, we started to deal with light as a wave, transverse wave, like how the wave will behave, how they will superpose on each other, what they will do once they will pass through different conditions like diffraction concept, polarization concept, all these things we have discussed. Am I right? So now what we are going to do is further development, in a sense like modern science. So like till there it is treated as what? Okay, fine, light is a wave, let it go, no problem. So light is a wave and many more things have been discussed and explained. Finally, scientists, they started to understand about the particle nature of light. So particle nature of light, of course this chapter is mainly based on photoelectric effect. Of course, in the first PU you have learnt about the inventions and discoveries of scientists. So in 1921 Einstein actually secured with Nobel Prize for his theories and explanation regarding what? Regarding the photoelectric effect. So that is what we are going to learn here. Before that, many other scientists who has given their theories and their discussions about it also we are going to discuss. So let us go for it. So we are not directly studying about this photoelectric effect. So this chapter is actually very important for one thing. I'll tell you. Nowadays, your calculator is solar, has got solar cell. Many of your house, of course, many of the house is been just they are using solar panels. Even using solar panels, power generation also been done in vast scales nowadays. So solar cell, solar panel, all this will generate electricity. So electricity means, of course, electrons, of course, free charge carriers, which will move from one point to another point when there is a potential difference. So this electrons concept, so when solar panel is kept to sun radiation, light will glow, of course, that. So electrons are made to travel through the circuit. So who is actually making the electrons to travel? That is what the concept is all about. That is what it is called electron emission. So we are not studying about solar cell here. Solar cell is something different. That is all about semiconductors. Something like photocells. Photocell in the sense something which emits electrons. So basic we are studying, not the modern thing. So I am just telling that from where and what we are studying in this particular chapter. So because of different advancement is done in this field for electric effect. That's why nowadays solar cell is there. Okay, hope you understood about it. So let us begin with that. So right now, let us go for chapter dual nature of radiation and matter. Okay, so now let us go for first, that is electron electron emission. Electron emission. Okay. Of course, you know that suppose a circuit want to work means, of course we know there should be a flow of electrons. If electrons direction of flow is being taken means, of course it is electron direction. Conventional flow of current direction means it is conventional current direction. It's just reverse, correct? So now electron emission, that means slowly when the nature of light is being much more developed, and of course the theory and discussions are made, even practical point of view, scientists started thinking, so wave nature of light is fine, but some of the concepts like, so if you use some of the metal plates, in the sense metal surfaces, and when it is illuminated, that means when it is, okay, suppose radiation falls on that, it shows some peculiar kind of characteristic, in the sense emission of electron takes place. That means emission of electron takes place by the metal surfaces. So that is what is being discovered by the scientist. In how many ways? Many different ways are there. Okay. That is first one, electron emissions. First we are discussing about electron emission from where? From metal surfaces. Okay. It is been found that it has been discovered that electron emissions, free charge carriers, okay, they start coming out of metal surfaces because of some reasons. What are those reasons? Of course, scientists initially they found out it is because of thermionic emission. Okay, so thermionic emission. Next, that means because of the heat field. Emission, that means because of high electric field, suppose it is applied to some metal surfaces, they will eject or they will liberate electrons. Okay, so third one is photo emission. So it was continuously being evolved, this kind of concept, like how the free charge carriers are being liberated from metal surfaces. One of the reason was by heating it, that is called thermionic emission. Second one is by applying the high electric field in the order of 10 power 8 volt per meter or Newton per coulomb, very high electric field. Next is like also by using the radiation or by light, you are able to, yes, of course you can do that. That means you can generate or you can eject electrons from outer surface of the metal. So these are the three possible things by which electron emission can takes place. Okay, so let us see what is electron emission. Okay, so electron emission means what? Electron emission is the liberation. It's the liberation of electron. Okay, so liberation of electrons from metal surfaces is called electron emission. So how many types of electron emissions are there? There are three types of electron emissions. What are those? First one is thermionic emission. So what is thermionic emission? If electron emission takes place from the metal surface by applying heat, is called thermionic emission. Next, field emission. So field emission means if a metal surface is subjected to high electric field in the order of 10 power 8 volt per meter, okay, You can see 10 power 8 volt or Newton per Coulomb. Very high electric field. And some of the metals, they will exhibit a characteristic of what emission of electrons from their surface. Electron emission takes place, and that particular method is called field emission. Third one, that is photo emission. So what is photo emission? So photo emission is nothing but electron emission takes place from the metal surface when a radiation of suitable frequency falls on it. Okay, so what is photo emission? Electron emission. Okay, fine. From the first let us come. What is thermionic emission? Emission of electrons from metal surface by heating it. Okay, next. What is field emission? Emission of electron from the metal surface by applying high electric field. Third one, photo emission. That means liberation or emission of electrons from the metal surface when radiation of suitable frequency is incident on it. So that's how you have to explain. Okay. So now let us go for what is photoelectric effect. Okay. So let us go for the definition now. So photoelectric effect. So what is meant by photoelectric effect? Of course, it's a photo emission, in the sense it's a phenomenon of emission of electrons by a metal surface, correct? When radiation of suitable frequency incident on it. That is it. Very simple, right? Same like how we have discussed for the photo emission. Here also it is one and the same. So photoelectric effect means what? The phenomenon emission of electrons from metal surface, correct? The phenomenon of emission of electrons from metal surface when radiation of suitable frequency is incident on it. Write neatly. What is photoelectric effect? The phenomenon of emission of electrons from the metal surface when the radiation of suitable frequency is incident on it. This is called what? This is called photoelectric effect. Okay. Fine. So definition is clear, I feel. And what about electron emission types? There are 3 types. So what is electron emission? The liberation of electrons from the metal surface. And right now we are focusing more on the whole chapter is actually based on this one, that is photoelectric effect. So mainly we require what is the definition of it? The phenomenon of emission of electrons from the metal surface when radiation of suitable frequency incident on it. This is called what? Photoelectric effect. Okay, students? Yes. Fine. That is all about photoelectric effect. So now let us go for the continuation of it. What is that? Let us see. That is, let us take a metal surface, okay? And according to this definition, it says when radiation falls on the metal surface, electrons will be liberated, correct? So electrons will be liberated. This is what it is said in the definition. Am I right? So now let us see what are the things which is required for liberation of electron. That means, suppose we take all the metals, whatever the metals you wish. Suppose we take and just keep it for sunlight, or light means whether it happens, of course it is not. There are some criteria or there are some limitations. There are some required things, okay. Some demand is there from each metal surfaces. That means metal surface means these are actually elements. They are having their own, what is that called, the characteristic, their nature, their chemical properties. So if a metal surface is supposed to emit electrons means there should be something which decides whether you are supposed to emit or not. Okay. So initially they took zinc as the standard prototype for the experimentation. That we will discuss later. Just let us see. Here you can see the diagram. The metal surface is there and radiation comes and falls on the metal surface. Imagine, what is that? Electrons are being emitted. So imagine the light is right now it is cloudy, correct, because of the rainy season. So that means if just light falls means whether it is bright light or dim light, whether both or whether it is possible, then there arises the question. Light means if it is very less intensity light also means whether it is possible for the metal to, okay, means what? Just liberate the electrons. They started thinking about it. And light means it is actually made up of particular wavelength, correct? Spectrum, you know. That means different frequency is there. So it all depends on wavelength frequency. That is what they came to know later on. Okay. So if you take a metal surface and if it is illuminated by a radiation means, if the metal surface wants to eject electron means there should be something. That means the radiation which is coming and hitting the metal surface is there. No, it has to be qualified. That means, okay, you are coming and making me to liberate electrons. Okay, fine. You should be qualified. That is what metal surface says. What is the qualification? Of course, that is what called, what is that? Of course, that is what called field emission. What I have said? Yes, photo emission I said, right? Correct? So regarding the emission only I am speaking right now. Of course, yes, light wave will come and it will incident on the particular metal surface, and the metal surface requires a particular radiation. Okay, radiation is there, right? When radiation comes and it hits, electrons will be ejected. To eject electron, that means whatever the radiation comes, where it is possible to eject from this particular metal surface is, answer is no. There should be something, that means there should be minimum energy which is required by the radiation which is incident on the metal surface, so that then only the metal surface will give the permission for emission of electron. So what is this? Let us see. Okay, so this is what liberation of electron taking place here, and this liberation of electron requires something called, okay, that is a minimum energy. Okay, what is that minimum energy required? That is nothing but work function. So what is work function means? As I told you, according to the basic rough diagram here I have shown you, right? That means a metal surface is there which is actually having the tendency. So the metal surface has the tendency to liberate electrons, but this requires something. Okay, it cannot liberate electrons for all the set of radiations. So the radiation also should be having the minimum qualification. What is that? They should have the minimum amount of energy. Okay, that should be capable of making the electron to come out of the metal surface. So that is what called work function. Okay, so look at here, work function I have written here. Work function means what? See, the minimum energy required. Okay, see, this is actually given by the symbol phi naught. Okay, in some book they will give by symbol capital W. No issues, better you follow phi naught. Now I have given you like that. In some books they will give capital W also. Okay, so the electron, if it wants to come out of the metal surface, means yes, of course it has to get some energy from the radiation. Am I right? So the radiation, when it strikes, the electron has to absorb some energy, then only it can come out, or else electron cannot come out. Of course, you know, free electrons, when it is there in the free conductors, means of course if you want to make the electrons to move, means of course there should be a potential difference, then only it moves, right? Similarly here itself. So what is work function? The minimum energy, the minimum energy required, the minimum energy required by an electron to escape from metal surface is called work function. Minimum energy required by an electron to escape from the metal surface is called work function, given by the form, that means notation phi naught. Okay, hope this is clear for you people. So I told you people, there are three different types of electron emissions. One is thermonic emission, field emission, one more is photo emission. So what is photoelectric effect? The phenomenon of emission of electron from the metal surface when radiation of suitable frequency falls on it. So whether it happens for all type of radiation, all type of metal, of course not possible. So there are some set of metals which are actually sensitive to light, and even though it is sensitive, there should be some basic needs. What are those? So simply the electrons won't come out of the metal surface simply like what, some, if the radiation falls on it, there should be some transfer of energy from the radiation. So whatever the radiation falls on the metal surface, it has to give an amount of energy to the electron. Electron will get the energy from the radiation, and then it tries to come out, and it is successful in coming out. Then only the photoemission takes place. That means the radiation has to be strong enough to make the electron to come out, means yes, that much of energy it has to pass through that, correct? So how it is passing? That is what dual nature of radiation of matter. Light consists of packets of energy, that is called quanta, correct? Of course. So that is what is discussed here in this particular chapter. Okay. So work function, of course, equation is written. Minimum energy required to liberate, or minimum energy required by the electron to escape from the metal surface is called work function. Okay. So right now we are discussing about the electron, all these things, and suppose you want to represent energies in joules, in all those scales, means it is slightly becomes a small magnitude. For this sake itself, for the sake of electrons, to deal with all these things, whenever you are coming across expression of energy, all these things, you require to represent this in electron volt. Okay, so that's why I am just giving you the definition of electron volt. So what is electron volt? Okay, So 1 electron volt, okay, 1 electron volt is a energy gain. Okay, 1 electron volt is the energy gained by an electron when it is accelerated by a potential difference of 1 volt. Okay, hope you can see this, what I have written at the bottom of the board. Fine. So 1 electron volt means what? 1 electron volt is the energy gained by an electron when it is accelerated by a potential difference of 1 volt. That means imagine that we are having a electron here and we are applying 1 volt here. That means 1 volt in the sense positive potential. When positive potential comes near an electron, of course, because of the charge characteristic, there will be attraction between a charge of opposite sign, of course. So what happens? The charge starts to move. When it moves, from the rest it's moving. That of course what will be there? Acceleration will be there. So what is 1 electron volt? So it's energy gained by the electron when it is accelerated by a potential difference of 1 volt. That is what called electron volt. Fine. So next, so let me erase this side. So now this photoelectric effect concept is there, right? So who discovered it initially? That is a question. Okay, so I hope you understood what is photo emission, from where it is liberated, that means electron emissions, how many types are there for electron emissions, so what is the criteria required like work function, all these things I think you understood right now. So let us go for photoelectric effect, who discovered it, all those things. Okay, so you might have heard about Heinrich Hertz. So Heinrich Hertz means Hertz experiment. So Hertz, the word Hertz, right? See, he is the person who is actually behind discovery of electromagnetic waves. Okay, so Heinrich Hertz, what he has done is he has discovered electromagnetic waves. In the sense, they knew that light is electromagnetic wave. All the other type of radiations coming, okay, fine, it's electromagnetic wave. They knew, but whether it is possible to generate it artificially, that is what was difficult. And one of the scientists was successful, that is Heinrich Hertz. He itself understood what? There is a concept called, there is a phenomenon is there. What is that phenomenon? Photo. What is that photo? In the sense, photo emission concept is there. He is actually the first person to discover it. Okay. So photoelectric effect or photo emission. Effect is discovered by Heinrich Hertz. Spelling of Heinrich Hertz, that is Hen, that means Heinrich. Heinrich Hertz. Okay, what he was doing is, I'll show you just rough diagram. He was actually performing an experiment. Okay, 2 metal plates were there like this. Whatever, simply one basic diagram. Okay, only 2 is enough because it's standard symbol. Let us take. Okay, like this. Two metal plates were there, and he has applied very high potential. Okay, when very high potential is supplied in between two metal plates, of course spark happens, correct? Spark is, of course. So sparkle or sparking takes place in between them. That means the charge will try to jump from one plate to another plate. Okay, that means I am explaining about the Heinrich Hertz experiment, how he found out there is a concept called photoelectric emission takes place. So he was performing, because he was actually the person who discovered the concept of the electromagnetic theory of light. Okay, that means in a sense he understood how to produce electromagnetic wave artificially, correct? By using a concept of capacitor and all, he is able to do that, and he was doing some experiment based on that itself. So he was doing experiment, like two metal plates were there, high electric potential was given, so it started sparking in between the plates. And while it was doing like, like when it was happening like that, he applied some ultraviolet rays. That means applied in the sense ultraviolet rays is being made to incident on the metal plates. Okay, when it falls on the metal plates, it is being observed by Heinrich Hertz that whatever the sparkling or whatever the jumping of the electrons takes place, it started enhancing, in the sense the sparkle of this circuit started getting enhanced. What is that? Becomes more and more when there is a ultraviolet rays is being incident on the metal surface. Thereafter he turns off, in the sense, okay, he blocks it. Now again normal. Okay, though there is a sparkle is taking place in between the two plates, it's right now it is steady. Again ultraviolet rays is made to fall on that, UV rays. Again it has enhanced. So he came to a conclusion that when ultraviolet rays is being incident on the metal surface, when there is a high potential is been applied to the metal surface and sparkle happens, or sparking. Okay, sparkle means, of course, even in Diwali and all sparklers are there. The sparking of electricity takes place. The sparking of this electricity gets enhanced, becomes more and more when there is a incident of ultraviolet has taken place. So by this they concluded as, yes, of course, what happens here, when there is a radiation of suitable frequency falls on metal surface, electrons will be ejected more and more. Okay, so that is what he explained. So by this it was discovered that there is something called photoelectric effect. A phenomenon is there in science. Okay, hope you understood it. Just have a look. So that is all about hope you understood about photoelectric effect. Is discovered by Heinrich Hertz, and actually how he discovered is, he was doing actually one of the experiment regarding the electromagnetic waves concept, and when he observed that when there is a high potential applied to two metal plates, electric sparks will takes place, of course. While the electric spark takes place, if ultraviolet rays is made to fall on that, the sparking of the electricity starts becoming more and more. That means enhancement has taken place. So due to this, what he has decided is, again he starts repeating that, and each and every time he finds whenever radiation of suitable frequency falls on this one, that means ultraviolet rays falls on this, more and more sparking, that means more and more electrons are being ejected to the surrounding space. Correct. So that is what they came to know, and that's how they discovered photoelectric effect. So hope this is clear for you people, like what is photoelectric effect, what are the different types of electron emissions, and who discovered photoelectric effect concept and how he has done it. Okay, yes, so let me erase this now. Yes. Next, let us go for one of the experiment. So Heinrich Hertz, of course, his assistants were there. So he has given the concept of photoelectric effect. His associate scientists, they have done one particular experiment. What is that experiment? Let us see. So the scientists' names are like Hallwatch, and Linard. Photo electric effect experiment. Okay, so Hallwatch and Linard's experiment. Okay, so this is actually the experiment which is being performed by them, and they have given their own observations also regarding this experiment, like what happens in this experiment and their theories. But some of them has got some basic drawbacks, and thereafter, because of their drawback, like because of the Hertz explanation, some of the concepts were like it was a drawback. Completely, it was not able to explain about the theories. That is been encashed by Einstein. He went in depth. He discussed, because he was very good in Einstein, of course, theories, maths, everything. Theory of relativity, of course, right, modern science. So Einstein adopted Max Planck's new, that means quantum theory or the modern science. He applied that in this particular case. So he was, of course, Nobel laureate, right, because of this concept itself. So Hallwatch and Linard's experiment. Okay, for exam point of view, okay, for explanation point of view, it will be for 3 marks and all. This can be asked. Okay, so what they have observed? So they have done some experimental arrangements. Like what? They have taken some tube, okay, evacuated tube, and thereafter they have taken one particular metal like zinc they have taken, and that metal plate is being kept inside a hole, that means a tube which is already evacuated, and radiation like ultraviolet rays made to fall on that. So once it is done, thereafter what else is being done is like they observed emission of electron has taken place, and then they started to give the explanation how the electron emission has taken place, what are the relation between electron emission and the incident radiation, and their observation they will give along with the experimental setup. And when all other scientists starts discussing, or when all other scientists starts study about it, some of the usually there will be council, right, which contains all different top scientists. So they started to find out some of the drawbacks. So some drawbacks also there. So in examination, always be careful from this particular topic. Explain Hallwatch and Linard's experiment on photoelectric effect means. Right now I am going to explain observation on photoelectric effect means. Yes, these people's observation. Okay. What are the demerits of photoelectric effect means? These people's demerits. That is the question. Okay. Yes. Let us see about it. Or one more question is there, that is regarding the Einstein's photoelectric observation. That is different. If it is mentioned Einstein, then only his observation has to be written, or else